This video covers material from Chapter 9, the Pythagorean Theorem. We are continuing with Section 9.3, looking at special right triangles. In the last set of videos, we were looking at the 30, 60, 90 right triangle and learned that the ratio of the sides is always the same. So today we're going to look at another special right triangle, the 45, 45, 90. So similar to yesterday where we started with an equilateral triangle, today we're going to start with a regular polygon, but we're going to start with a square. So given a square with side lengths A, so let's write those in. We have side lengths A, and what we're going to do is we're going to draw one diagonal. So we know that the angles of a square are 90 degrees, and when I draw on this diagonal, I'm going to bisect the angles. So I can see I form two 45, 45, 90 triangles. So we're just going to focus on the one here. Let's call this D for the diagonal. And we can already see that if we're just looking at this triangle here, that the ratio of the legs is 1 to 1, because these are both the same value, because this is an isosceles right triangle. Remember, these are two sides of the square, so they have to be congruent. So now we want to see, well, what's the ratio of the two sides to the diagonal. So like we did with 30, 60, 90s, let's use the Pythagorean theorem. So I've got d squared is equal to a squared plus a squared. So d squared is equal to 2a squared. Then we'll take the square root of both sides. Remember, square root and square, they're inverse operations. They undo each other. So the square root of d squared, just like the square root of 3 squared would just be 3. 3 squared is 9, and the square root of 9 is 3. The square root of d squared is just d. And then I'm going to separate these and rearrange a little. So I've got the square root of a squared and the square root of 2. Remember, a property of radicals is I can split them up. As long as it's multiplication or division, I can give them each their own. So then I get d is equal to the square root of a squared is a root 2. So this side turns out to be a root 2. And we can see that no matter what the value of a is, the ratio of one leg to the other leg to the hypotenuse is always going to be 1 to 1 to root 2. Okay, a little different than what we had for 30, 60, 90s, where it was 1 to root 3 to 2. All right, so let's go ahead and fill in our information for our 45, 45, 90. So in any 45, 45, 90 triangle, the ratio of the legs to the hypotenuse is always 1 to 1 to root 2. Alright, so if you want to rewatch, if you feel like you missed something, that's always a good idea. Sometimes it's a good idea to watch it through one time and then watch it through again and take the notes, or do it in the other order. But at any rate, if you have questions, make sure you get those answered. And we'll look at a couple examples in the next few videos.